All right, we're going to go and get started. It is 10:30 a.m. and we welcome you to Advanced Kentucky's AP Calculus BC mock exam scoring session. My name is Aaron Timmons. I'm the Advanced Kentucky Content Director for Mathematics. I'm joined by our presenters today, Dr. Alex McAllister from Center College. He's the AP exam leader for College Board. And then also we're joined by our Access to Algebra Content Manager, but current AP Calculus table leader, Michael Marshall. So before we get started, we're going to go over a couple housekeeping procedures. Please make sure you have today's handouts and materials from the bit.ly link on the screen there. So just a couple disclaimers here. We have designed this event for Kentucky teachers to receive guidance on the scoring of AP exam mock questions. If you are not an educator or causing a disruption to the session, you will be removed. Please make sure you are acting appropriately. AP and Educational Testing Service were not affiliated with this session or these questions, so we have no insider information on what the exam will look like here in a week, but we are taking our best guesses. Contact information for Advanced Kentucky and myself are on the screen here. Please feel free to shoot any questions you have afterwards to us and we will get back to you. Your microphones will remain off for the duration of this meeting. Your videos we ask that you keep off as well. If you turn them on or if you're doing anything wrong, you'll be removed. Please make sure you are using the chat feature. You can chat directly with myself if you have questions about any of the things Alex and Michael are saying, and then we will get those to them and they can answer directly. The link is bit.ly/mockexam2020. I'll post that in the chat here in a second. kyap2020.com is where you can go to find today's recording. You can find previous content review session recordings for students and teachers, as well as the AB session if you missed that on Monday and need to see any of that. And I think that is all I've got. So I'm going to stop sharing my screen. I'm going to turn things over to Alex and Michael. They can give you all a little bit of background about where they're coming from and their expertise. And guys, take it from there.
All right, I'm Michael Marshall. I've taught AP Calculus, AB and BC for about 13 years at Scott County High School in Georgetown, Kentucky. I've been a reader for the past 5 years. This year I'll be a table leader for the distributed reading, the online at-home reading. I also work as Aaron said, I'm the Access to Algebra. It's a middle school program with Advanced Kentucky. I'm the content manager. I'm excited to be here today. Alex?
Yes, I'm Alex McAllister. I teach math at Center College here in Central Kentucky. I started participating in AP readings back in 2020, and I've had the good fortune to be able to keep coming back for every year since then. Doing different work as question leaders and table leaders in the last couple of years. I guess 3 years I've been an exam leader, and I get to be part of that again this year. So hopefully we're going to share with you what kinds of things happen there and some of our guesses and what might happen there this coming year. We had a real right focus on wanting to think about what would be helpful for students and being ready for this new test. Part of our big goals, is to share the kind of fair, consistent roadmap to assigning credit. Every time we get together to try and create scoring guidelines and figure out how to grade things for partial credit, they're intense, lively, fun conversations, because we care about our students, we care about the mathematics a lot, and I know even we can wind up with different divergent perspectives on whether something's worth a point or not, and so part of the hard part of being a reader and participating in the reading is we have to compromise a little bit sometimes to reach a consistent, fair roadmap. If you can imagine, we've got 500 people that we want to grade the exact same way. And unfortunately, know a lot of mathematics, we could do that, but it can't be the same way that everybody wants. And so we're going to share with you, the roadmap we've come up with through conversation these last couple of weeks. We're going to practice using it along the way so you can look at your students' work and grade it too. I do want to say, this no inside info on this year's tests or cut scores. I really, usually for me, I show up a couple of weeks before or a week before the reading. I get some material 2 weeks out and look at it for the first time, and that's true here too. I really have no idea what this year's exam is going to look like. Kind of made some guesses on things and assuming some consistency from some things in the past. I think for me, I don't know, Michael, maybe you haven't thought about this, designing this BC2 piece was the hardest part, because I felt like the AB1, BC1, I felt like, what are we going to talk about? Limits, derivatives, and integrals. And then diving in a little bit more to some of the quantitative stuff, touching on mean value theorems and approximating the Riemann sums. I know BC is really different because of series, but there's some things on that AB2 that we didn't touch on in this BC2. And so I don't know, if you're a teacher, maybe you want to have your students look also at AB2.
Right. That's a good suggestion.
Yeah. Let's see. So anyway, yeah. So fortunately, right, ETS and College Board, we can go ahead and share this with you, but none of this is representative. It's just based on our experiences and our thoughts of what we've done over the year. And then we want to have some fun along the way, right? We love calculus, we love math, so hopefully we'll have a little bit of that too. It's good to be active and having a blast doing math on a Wednesday morning. Well, at least that's what it is here in Kentucky. The plan, right, talk through the BC2, grades in BC2, and then we were going to open it up to questions about BC1 at the end of this. So I don't know, what do you think? Ready to dive on in, Michael?
I'm ready to go. Oh, Aaron.
Just a quick disclaimer. So those of you that may have not tuned into our AB session on Monday, BC1 is the same as AB1. So if you are wondering why we're not going to really discuss that one in depth, you can go to kyap2020.com and find the recording of the AB1, BC1 briefing along with scoring samples and scoring guidelines.
All right. Sounds good.
And then,
all right, well,
sorry, one more thing. So questions that you all have during Michael and Alex's presentation here, shoot those in the chat, and then after each part, then I will give them the questions that were most common. All right, now I'm done.
All right, so let's dive into BC2. So what do we do for this question? We gave students a value, values of, right, so we're given a function g that derivatives all orders, and we tell them the values of the derivatives at x equals 0 at select points. And then we define this other function f, right? 1 plus the integral from 0 to x of g of t. And so all the questions are about playing with these two functions. We ask them to first write down the third degree Taylor polynomial for f about x equals 0. And then we do this thing where we ask them to, in part B, we're asking them to think about the that Taylor polynomial. Imagine it's a geometric series. That, right, and what happens when you plug in x equals 4 and make a decision about, right, what's the sum of that series, or does the series diverge at that particular point? In part C, we then go ahead and ask them to integrate the function, and then, right, use that, right, well, I'm sorry, so actually what do? We find the third function, h of x equal to integral from 1 to x f of d dt, and then use that Taylor polynomial to approximate this new function h at 1/4. Okay, and then the last thing is we kind of hop out and look at a separate series, right? The series, we've got the sum from 1 to infinity and -1 to the n divided by the third root of n. And make a decision about convergence or divergence there and explain the reasoning. Okay, so what do? We think about the scoring guideline. We lay out how we're going to assign points. We made the choice, usually questions have 9 points assigned across all the different parts. In order to work out the 60%, 40% ratio, we decided to make the BC1 worth 15 points and the BC2 worth 10 points. I don't know if that'll happen or not, but that was a guess we made to try and preserve those ratios. And what are we going to do? We're giving on the left-hand side there of your screen, right, is a solution. We talk about what are the values of f of 0, f prime of 0, f double prime of 0, right, the third derivative at 0, wanting them to pull those values from the table, and then put it together to create that third degree Taylor polynomial. We're envisioning that this would be worth 2 points. One of those points would be for 2 terms, any 2 terms, and then the other point is for the remaining terms of this Taylor polynomial. So let's dive in a little bit more detail, right? What's going to actually definitely earn those points, and what would earn partial credit, right? Are there ways to get just one of those points? So yeah, as we said, right, the first points for the 2 terms and the second points for the remaining terms. Both points are awarded if you have a correct third-degree polynomial. And they can just state that correct polynomial. The numbers aren't complicated. We're willing to let them do a little bit of that arithmetic in their head if they put it together perfectly. We're going to emphasize the first points for any two correct terms. So we'll see some examples in a minute. You might imagine someone leaving off negatives or right, messing up the constant term, but getting the next two terms right. So we're not going to require any two particular terms to be correct, but at least two to earn that first point. And then the second point is for the other two terms, and they have to, right, to earn it, it's got to be perfect to earn that second point. Anything, so we've asked them for this third degree Taylor polynomial, if they have anything beyond the cubic or a plus dot dot dot, right, if they indicate they're thinking of the Taylor series rather than the polynomial, that they haven't actually answered our question, and we're going to be careful with that boundary, and because we want them to know the third degree polynomial, Taylor polynomial, should, well, in this case would actually be a cubic. And then we're also going to, so this is a choice that we give a little bit of grace to students, and maybe being a little bit messy with notation and using equals or approximately. It can be really hard to try and distinguish between a straight line and a slightly wavy line. And so this will be a place where maybe we'd be a lot more strict just in our classroom, but we're going to give a little bit of gentleness in evaluating those if they show up. So what I've got here, just some examples to think about going through and grading things, are some things that would earn full credit, right? So we're not going to require them to necessarily simplify the Taylor polynomial. We might see factorials sitting in those denominators, or right in the example B there, right? We got an f of x equals, right? That doesn't have to be there, but it's fine if it is. And right, we're okay if they multiply out the factorials. And then that last version, right, just to kind of highlight the approximately is something we'll accept. We'll let them simplify 8 divided by 2. This is where, especially we're talking about BC students who are often right, very right, mathematically adept. That might be a simplification that they would do, that as long as it's right, providing exactly the correct polynomial, we'll allow them to earn those points. So a couple things that don't quite get there, so we might see things like this, right? So what's the error here? Right, the students lost the negative on that second term and on the linear and the cubic terms, but they do have, right? They do have the first and right, the constant and the quadratic term are accurate, right? They have two terms, not consecutive. We're not requiring that, but they have two terms. So they earn the first point. But then it's not perfect, so they don't earn that second point. So this is a case where, right, what's happened here? The constant term, we've got a 3 for some reason, and then they've added on a fourth term, or a quartic term. So what are we going to do? We're going to look for two correct terms. What's this student done, right? They have the minus 2x plus 4x squared correct, so they earn that first point. But then the rest of it doesn't matter if they have more than one error, right? The other errors result in them not earning the second point. Okay, and then this last example was just to highlight, oh, this looks perfect. Oh wait, oops, no, actually it's not. This has the missing pluses or plus negative signs, and it's got the plus dot dot dot. So yeah, actually they don't. This is kind of it's not working well at all, right? So we've got a 0, 0 here. The student does not have two correct terms, so they can't earn the first point, and then they're not going to be able to earn that second point. Okay. Oh yeah. So now we're switching over. We're gonna let you guys do some polls and think about how you would grade them based on what we've just shared, and then and Michael's going to talk through on these.
Yeah. So after each one, we're going to have some snippets, and you're going to grade them with a poll that Aaron will put up in a second. I just want to give my little spiel. Today is meant for educators, so we wanted just to give you a taste of what it's like at the reading. A lot of people think it's just they hand you the scoring guidelines, and that is not it. There's like an hour-and-a-half briefing for each one, so that's kind of like what we're doing today. So you could always see how Alex went in depth. That's how they do, so that everybody is consistent. So Aaron, you ready for this one? We'll give you 20 seconds.
Responses are anonymous, so please participate.
And you can move that poll window if it jumps up in front of your snippet. All right, so this one, the student has -2 plus 8x plus 48. There's no correct terms, so it is a 0, 0.
Oh. Well, having problems with my box putting the 0, 0 in. There we go. All right. Okay.
All right, next one, Aaron. All right, so this student, it looks like they have 1 minus 2x, that's correct, but they've left off the factorial, so those terms are not correct. So they do have 2 terms correct, so we're gonna say this is a 1, 0. Okay, our third one. Okay, let's see, they have 1 minus 2x, that's correct. They have 8x squared over 2 factorial, correct, minus 48, but they're missing the x cubed. So we're gonna score this one as a 1, 0. But they don't need to simplify the factorials. Good. And the last one. All right, on this one, the student just blurted out the answer. I know you might hear about no bald answers. There is nuance to that. For this particular problem, we are allowing them to just write the correct polynomial, and they've simplified it correctly. They put it together correctly. We're going to call it an abrupt answer. So we're going to say a 1, 1.
Yeah, and that point about there are places where we definitely do want to see work to support answers, and we'll see that in this next part. This particular one, right, Michael shared, seems simple enough that we're willing to let them get the perfect thing right away.
Were there any questions?
Oh yeah.
No questions. Some people want a little bit more time on the polls, so we'll do that for the next parts coming up. We'll give a little bit more.
Okay, we'll do 25, 30.
Yeah.
Okay.
All right, so let's go on to part B. So we want to share with you, right, remember what the question is. So what we're doing is we're saying, right, take that, that Taylor polynomial that the student just found, and let's think about it as a geometric series. And then what we want to do is right, find the sum of this series when x is equal to 1/4, or show that it diverges when x is equal to 1/4. And so on the left-hand side there, right, we have like, okay, we're thinking about this now as a series, a geometric series. We substituted the 1/4 and done some arithmetic. And the hope is, right, the student will recognize that the radius, the r in this case, is a -1/2. And conclude that, right, since the absolute value of that r is less than 1, that the series converges to, and use our summation formula, right? First term over 1 minus r, in this case, the 1 over 1 minus the -1/2, and conclude 2/3. And so what are we gonna look for, right? We thought about this part as having 3 points to it. That recognition that the r is a -1/2. We want them to see about, right, this decision point they need to reach between whether the series converges or diverges, some indication that they communicate how they reach that conclusion in moving forward. So we frame that in terms of this considers that absolute value of r is less than 1. And then the last part, do they, right, it does converge. We ask them to find the sum of the series. So that's what that, that fifth point is for, or the, right, the third in this part is the sum of the series. Okay, so let's break those down a little bit more. What are we going to be looking for in this third point that identifies r equals -1/2? So there's several different ways this can happen. The student may explicitly tell us r is equal to -1/2. We've seen student work that does that. We're also going to actually allow the student to identify the -1/2 implicitly. So if we see the student right on the scoring guideline, if you look at what's written there, sorry, I'm just flipping over the page for myself. Right, we've got the 1 minus 1/2 plus 1/4 minus 1/8. Right, if the student goes on and re-expresses that quarter and that eighth, the -1/8, in terms of this -1/2, right, we're going to allow this, think of that as the student expressing to us that they've recognized that the r is a -1/2 in this geometric series. I've got two examples up there because, right, we need the students to be careful in particular with that negative sign when they're working with this radius, right? That if they've restated the series incorrectly, then it's not clear that they've definitely communicated. No, they're thinking about a geometric series with the -1/2. We'll allow this negative to kind of sit there in front of that first power on the 1/2, but we have to be careful back here on that third power in these implicit cases. Okay. Oh, one other way in which we'll let our students identify the r equals -1/2 implicitly and earn this third point is if we see in the summation formula, right, that first term over 1 minus r, they don't have to write out this the actual like generic version of the formula. We'll let them just write this 1 over 1 minus -1/2. We're going to think of that as an indicator that the student has recognized that the r is a -1/2. I know this kind of third version of implicit was the one we spent the most time talking about, whether that is something that would, and we decided it kind of just barely met the threshold. Let's see, one more thing about this third point. We will allow the student to earn this third point if they say the absolute value of r is equal to 1/2. That's a correct statement. There will be a place where this student actually has to be right, more careful with the sum in a minute. And so that recognition that the -1/2 will play a role in another point. But this first place of entering the question will also allow that to earn the point if they recognize the magnitude as 1/2. Okay, so that's the third point. The fourth point is, right, what's the idea is we're looking for determination of convergence and context, right? We've let the student know, right, either find the sum or decide it diverges, right? There's a path, the choice that the student has to make. We want them to go ahead and tell us, right, which one of those they should choose converges. And so how are they going to go ahead and communicate that? So we'll think about it, right? They can express it symbolically, right? This absolute value of r is less than 1. We'll let them work with the interval -1 less than r less than 1. The student can use words, right? The absolute value of the radius is less than 1. All of those are fine ways to express this determination of convergence. We do need to see it contextually. So not just, I guess it's the next one, right? Not just the formulaic absolute value of r is less than 1. We need to believe that the student has actually engaged with our question. And so some numeric value attached to the r rate. We already talked about explicit or implicit ways to express that, but some kind of engagement in the context of our question. Let's see, stating convergence is not required. We actually haven't asked the student to do that. We asked them to find the sum of the series. So we're not going to require that, right? That's why we've chosen for this idea of looking for determination of convergence. But we also want to say that stating convergence is not sufficient. The student has to communicate what they're thinking about, right? How they landed on that conclusion. So it's a little bit more, and that's partly how we went with this phrasing of the fourth point. Okay, last point, the fifth point in this section on the sum of the series. What are we looking for? The student earns it if they have the correct sum, and then we need supporting work with r equals -1/2. So the student might have 1 over 1 minus -1/2. I did wind up, I almost wrote 1 question mark 1 there. Yeah, so just to be clear, we use these question marks yet? I think that the idea here is we're kind of focusing in just on this one particular point, and there'll be more work on the page, hopefully, that would tell us whether or not they've earned the third and fourth point there. So we're just focusing in on, right, presents this series, that would be something that would earn that fifth point. Let's see. If the student, yeah, right, so we see the 1/1 minus a half. So this is a thing to watch for. It can be kind of tricky, right? Lots of all the negatives sitting right next to each other. There's a place to be really careful in reading. Right, that's why we have calculus teachers do it, right? Because we're experts and we know, right, we can recognize when a negative's on there or not. Other people probably could too in that case, but we just have to watch for that, and that would not be sufficient. Oh yeah, I needed to mention, I just wanted to share with you, right, what are the values of these? These can be things that can be, you can think of as flags that help you, right, locate whether they're gonna earn this point or not. It turns out that the correct sum is 2/3. The student is allowed to also present the decimal version of those. And so I'll say more about decimals in a minute, but in this case, right, it's 3 places is what we're looking for, correct, either rounded or truncated. So they can present the 0.666 or the 0.667 and still earn that fifth point, right? You don't have to do any of these, but any of these is acceptable in the presence of supporting work, okay? You have to have that version of first term over 1 minus r. If the radius is not plus or minus a half, then the student's not going to earn any points in this part of the question. We really, in that sense, there's a high bar for eligibility to be able to enter this. We expect them to work with our geometric series. Well, almost. Actually, I wrote positive 1/2 there. So let's talk about that. Oh yeah, so before I talk about the positive 1/2, just to make sure we're okay with how decimal presentation errors work, right? What are the requirements of the exam? The final answer should be accurate to 3 digits after the decimal point, rounded or truncated. And so what do we do if a student makes an error? They don't earn the first point they would have, the first available point. And then the process that we go through, we don't want decimal errors to completely knock a student out of every possible point in a question. So there's this idea of immunity that they can earn all the subsequent points with correct or consistent answers, rounded or truncated, and the 1 or 2 decimal digits. So there's 1 point that would not be earned out of the 10 that are available here. It does show up again in BC1, right? If they make that decimal error, they can lose another point there. And so I actually, the times when I talk with students, I say, right, out of almost all the rules around this, right, you don't know all the rules of calculus, here's a rule that you can be very careful with to protect yourself points on. We don't want students to lose points for these, or not earn points for decimal presentation errors, but right, it's part of the rules of the game is being careful with that piece of it. So let me say one piece, there's one possible exception to how we've laid things out based on the correct approaches. We're going to allow one eligible import from part A that can lead to a slightly different geometric series. And that's the case for the students left off the negatives. So this is a thing we do sometimes, right? Students will give good work that is not quite right, and then there's an echo that can happen. And we're not always going to read with every possible solution, right? We can't have students just saying, hey, I want to do this question instead of the one you gave me, and then try and figure out a roadmap for that. But we will allow sometimes information that's close enough to carry down. And this is a place where there's a lot of conversation at the reading, right? What are the places where something from one part can be brought down into another? We landed on the choice that we would allow this one possible import, 1 plus 2x plus 4x squared plus 8x cubed. And so what happens when you substitute in the quarter, you do wind up with a geometric series. And so that allows us to go ahead and grade consistently, and allows us to let the student earn all 3 points. And we'll do the same thing. Now we would expect to see an R equals a 1/2. The same kind of pattern for grading, right, indicating determination of convergence and context would apply here, although now we'd be working with the 1/2 instead. And we're looking for the sum of the series, again, with supporting work. This one turns into that, right, now that we've got the positive 1/2, we'll be looking for 1/1 minus a half equals 2. That thing that didn't earn the point would, right, with the R equals negative 1/2, will earn the point here with R equals a half. So we need to have a clear indicator of when the student, or if the student has landed in this place here. And that's right, again, it's probably why great calculus teachers do all this, is so we can make that determination of whether the student is in this import case or whether they're in working with the question that they've been given. So I think that's all I had for, we're up for snip time.
All right, so I'll give you a little more time this time. Let's do 30 seconds. So here's our first snip. So Aaron, when you get the poll up, wait for 30 seconds. All right, when we look at this one, it looks like good work. They've got the correct geometric series. They've identified, not directly, but if you look in the parentheses, I see a -1/2. So they're going to earn that first point. So it's a 1. I don't see that they've said that the absolute value of R is less than 1. So they're not going to earn the middle point. But that expression that they have the -1/2 is the correct sum. No need to simplify. So they will earn the last point. This is a 101. All right, next one.
And we're going to tweak our way. We're going to let people view the slide here, and then we'll put the poll up so that people can see it. It still has some issues with screens. So
Okay. Yeah, the poll pops up right on top of it, so I always have to scoot it over. All right. So on this one, it's very similar to the last example. They've explicitly said that R equals -1/2. So they've earned that first point. Here they've said it converges, but they still didn't say why. They did not say that absolute value of R is less than 1 or some variation of that, but they did earn the sum of the series point. Again, no need to simplify that. So a 101 on this one also. All right, polls up. Okay, on this one, yes, they've identified R equals -1/2. They've earned the first point. They've also said the absolute value of R is less than 1. So that's the second point. They have the correct sum, but then they simplify it wrong. That unfortunately makes them not eligible to earn the last point. So they have scored a 110. Okay, it's our last one for this part. Polls up. So this one, students taking a little bit different approach. They decided to like verbally tell us that if you plug in 1/4 into my answer and from A, you get a geometric series with R equals -1/2. Okay, there's the first point they've earned. And since the absolute value of that's less than 1, oh, that's the second point. It converges to 2/3. That's the correct sum, but there's no supporting work. We said there needs to be supporting work for that. So this is a 1-1-0. I hate that for the student, but that's how it's scored.
All right, handful of questions. You may have already addressed them, so forgive me if I am being repetitive. First question was, if you write the series using sigma notation, sigma 0 to infinity, -1/2 to the n, can they earn the point for R?
Oh yeah, so that would be another. It's thinking about the kind of implicit presentation. Yeah, if they've written that out, absolutely. Yeah,
right.
so that would be something we want to add. That's a great question.
So someone wanted to know just kind of your thought process as to why you will accept symbolic expressions for R, but not just a formulaic approach.
So let's see. So I think let me go back to the slide that I think that's from and see if is this? It's asking me the question again. I think is this the?
Yeah. So why can they earn a point for expressing symbolically, but not just formulaically?
Oh, so I guess the highlight to me here is this point about in context. So when I was thinking about it symbolically, I was thinking that right, because it really doesn't look like a lot of difference between that second bullet point and the fifth one, right? they're kind of different, but the key is the context. We want to have the student actually engaging our question in context and saying, right, not just, oh, geometric, of course, right? What's the one of the things I remember about geometric? Absolute value of R is less than 1. Right, that's some base knowledge we want, but we need them to actually use it in the question. And so once they've told us something about the R equals -1/2, once we know they're working with that geometric series, then we can let them go ahead and talk about, right, they've told us an R, now they can talk about that R is less than 1. The difference here is just kind of, you can imagine a blank page with an absolute value of R less than 1 on it. That's not sufficient to earn a point. Do you think that gets at the question, Michael?
Yeah, I think what we're saying is you cannot earn the second point without the first. Does that seem fair? So if you just slap absolute value of R less than 1 on the paper and you don't have the -1/2, like Alex said, that's what we mean by not just formulaic, because they've memorized that. So yeah, so I would say the best explanation is you can't earn the second point without the first.
All right. And then I think you've discussed using incorrect R values, reading with wrong values of R. And then someone wanted to know about if they had the wrong polynomial from part A, but used it correctly, could they earn more points? That might come up later on, though.
On this one, there was only one acceptable import.
Okay. All right. So there you go. All right. Then that was it.
There is that question about bringing polynomials down is a hard one, right? In terms of every time but we do want to be able to let students carry down their work, but there has to be some kind of boundaries on that. And there's a little bit more generous take on it. We'll see in one of the next parts.
Yeah, I think you can also say, like, this isn't a set rule, like, oh, well, that's how it always is. Every question is different. There's, the higher ups that I'm not involved in decide what is good enough and what is now, and you do what you're told, and that's just the decision was made.
Yeah, and I would want to add to that. There really is a lot of discussion that goes into those kind of boundaries. Partly, I think for us, I've come around to thinking about this. There's the main reading that happens. Before that, there's a week of work, and question leaders and teams prepare stuff and share them with the table leaders. And the kinds of questions y'all are asking are like spot on with what would happen in that conversation in terms of what needs to be clarified, what needs to be addressed. And they might be looking at, right, part of when table leaders first see this, they're going to look at a whole bunch of student work, and they might see other imports that look like really close that maybe they think should have credit, that that in our conversations the last couple of days we hadn't thought about. So there's some really rich consideration of, right, should this eligible import be flexed a little bit? Or, right, are there reasons why, no, we really need to limit it to this one in particular? So, yeah, hours of conversation by people that care a lot. So these are great questions. What do you think, Michael? Ready to go on to the next part, or sound good, Aaron?
Yeah, we're good.
Okay. So we are on BC2, Part C, and in Part C, we're going to be thinking about, again, still about that Taylor polynomial found in Part A, and we're asking them to do some integration, work with the 0 to x, f of t dt, and then approximate h of a quarter using that polynomial. And so we landed on wanting to think about this in a similar fashion to what we did in Part A, where the first point's for 2 terms, and the second point, or I should really talk about this point where it's 6th and 7th points, remaining terms. And then the last one is for the approximation, and they work with a quarter. And so, sorry, actually the reading is going to be very similar to the way we talk about students earning points to what we just did in Part A. Right, both points for a correct 4th degree polynomial will allow, again, the students to just state the correct polynomial. The 6th point is for any 2 correct terms. It doesn't have to be the first 2 or, right, any particular ones, but any 2. And then the 7th point is for the other 2 terms in the Quartic. So again, it's got to stop at the Quartic. We can't be looking at things with fifth degree, 5th degree terms or plus dots, right? They've been asked for a polynomial, and there's that space with the equals and the approximately's. So here's some correct answers. These are all ones that are going to earn both the 6th and the 7th point. We might just see the polynomial written down, perhaps some simplification. The students might, right, leave everything in terms of fractions, right? The whole raised to the power 1 divided by the new power. We might see that written out explicitly, and then they can just stop. We don't need to see numbers pulled together. Or we might see some algebraic simplifications, right? Maybe we'll see that instead of it's 4/3 on the cubic term, maybe we'll see 1.333 and write them using that 3 decimal place expression for 4/3, and that would be something that would allow them to earn both points. That is a place I would say as a teacher to caution students, or I would for my students, because we are asking them to actually work with a quarter in a minute, right? And that intermediate rounding can be a place that can wind up with incorrect approximations. It turns out this one's robust enough that will be okay, but that really is a place to be. I think 4/3. I like the Part A or A answer better. So let's see, and then, right, what would be things that would earn partial credit or earn one of the points, right? Again, there might be sign errors that could carry down, and we'll let the student earn one of the 2 points, right? They actually have 2 correct terms, right? The x and the 4/3 x cubed. So the student has an anti-differentiation error, right? The original, they just didn't anti-differentiate the constant term. They also put in a 5th degree term. So, but they do have 2 correct terms, right? They've got the minus x squared plus 4/3 x cubed. So they even have a 3rd one, but it's not quite enough, right? You have to have all 4. And then this student has it looks like the whole correct polynomial, but they've got the plus ... on there, and so they're not going to earn that 7th point. What do you think? Anything else I should add in there, Michael? Does that look right?
I think that covers that.
Okay. All right. So let's talk about the approximation then. I think that's what's next. Yeah. So the eligibility. So this is actually a hard one to think about what an eligibility is going to be on. I think we landed on what we think we'd like to do is have the student earn the 6th point. And we'll be looking for numeric values equal to the 77 over 384, which is approximately, right, 0.200 or 0.201. And so what are different expressions that can earn this 8th point? We might see them with the 1/4 plugged in everywhere. The students aren't required to simplify. their numeric presentations, right? We're looking for numeric values equal to this. So this turns out to be a correct numeric expression to earn the approximation point. Here's another version of it, right? Where they've distributed those powers. Maybe they've done some canceling or not. And we might see students, so I wrote out more terms, and so you can see the rounding or truncating piece, right, why we went up with the 0.200 or the 0.201. There are, right, we do have to be careful on this approximation point. Just reaching the correct decimal is not necessarily guaranteed that you've got the point, right? So you can see this student who right, somehow made some arithmetic error, wound up with 78/384, which is approximately 0.200. Right, we can't just look at the 0.200, we have to look at that preceding work. And if they made an arithmetic mistake, they are not gonna earn this 8-point approximation point. Or you have to have correct work giving you the correct answer, not incorrect work giving you the correct answer. Well, also, let's see, so what was the idea here? Oh yeah, so did I have a, let's see, so what's going on with these slides? Yeah, so this idea that the student only needed to earn the 6 point. So how can that happen? Right, this student has right the linear and cubic terms correct, but then they've lost the negatives, the other two terms. So this student would earn a 1-0, but then we're going to see them go ahead and plug in the 1/4 everywhere. And so this would be a place where this student would actually earn a 101, that allowing them to only requiring that 6 point is going to create some potentially very different numeric approximations. Similarly, right, this next one, the student who got our plus ... on there, so they've got a 1-0, but then they go ahead and substitute in the 1/4 and stop there. Right, they then truncate that off. That's a student who can earn a 101. I think a thing Michael and I talked about a little bit is at the reading itself, this eligibility criteria might be a little too generous, just in terms of, right, one of the goals is consistency in grading, and you can imagine students could do all kinds of work with fractions to make mistakes along the way that can be hard to find. And so this might be a place where we'd ask table leaders to try it and to go ahead and see, right, do these numbers work out well? What we'd like to leave it this open, but we have to make sure that we're being consistent as we go along. So somebody asked the question about imports from part A. We're going to be a little bit more open with imports from part A in this place, where we're going to ask a student if they present a cubic polynomial with at least 3 non-zero terms. So what are we going to be looking for? We need that leading constant, or the constant on the x cubed can't be 0. It really needs to be a cubic. And then 2 of the A, B's, and C's have to be non-zero. So we'll allow those imports, and how will we grade or read those? The 6th and 7th point we'll read above, but we'll be looking for consistent Quartic polynomial antiderivatives. So, right, so you see that polynomial over in part A, and it is, right, it meets this criteria. It's one of these cubic polynomials. You look for, right, did they anti-differentiate correctly for their polynomial? And we'll allow them to earn both of those points for the antiderivative. But then the student's not going to be eligible for the answer point on this, or the approximation point, I should say. That we're not going to be thinking about plugging the quarters and doing all the different arithmetic there. We're allowing them to earn those antiderivative points though. Okay. Oh, Snips.
Before we do the snippets, Aaron, do you want to address the 2 questions that went to everyone?
Yeah, so the question that came up was, what if students do not explicitly write the polynomial since it wasn't asked for in the question?
So let's see, I'm sorry, I'm backing up to look at the scoring guideline. So we're asking basically if the students enter right here.
Yeah, that's another question. Would that earn, let's skip to that one. Would that earn all 3 points? Just what you have boxed in. I think that's even, we have an example of minimum accepted coming up. I think that would also be in that same category.
I think you're right. Yeah.
Yeah.
I think that we would think about, because whoever asked the question is absolutely right. Right? We didn't ask for the polynomial or ask for the antiderivative. There, we asked them to use it, and so then right, we see a pretty clear indication that they've done that anti-differentiation. I do think that right, the student does have a responsibility to, right, if they start multiplying all this stuff out and cubing it, right, if there's too many things combined in here, I don't remember what 2/1/4 to the fourth turns in, but if they start doing simplifying arithmetic, there's going to be a threshold at which it would not earn that, I think.
Yeah.
But this is very clear in terms of laying everything out, and it's about communication, right?
The other question was, let's say they had the integral, so the very top line, they've written that.
Okay. So let me switch.
You know, the integral from 0 to x. Yeah.
Okay.
And now they've used, I assume, Math 9 on their calculator and did 0 to 1/4. Stephanie, I know you are. Am I asking that correctly? You can just say yes in the comments. Thank you. So yes.
Oh, so they presented that, and then the student goes down and gives us like this, right?
Yes, because they use Math 9.
Those two circled things are all they present.
Yeah.
Yeah.
I think that just got into the new territory of the calculator is not required, so I wasn't really thinking of it that way.
Yeah. I think I would have to say I'd have to go think about this a little bit. My initial instinct is to be hesitant to award full credit for that, because in some sense all the student has done is rewritten what's been handed to them in the stem of the question, and right, the variable x they're plugging in the 1/4 in both places, and so I guess I'm saying I think there's a place where students have to show their work and have to communicate what they're accomplishing, but I don't know. I guess I would also say I don't know the rules about calculators for this year. Most of the time when these series questions show up, they're in the non-calculator portion, and that would be evidence that the students cheated in some way. But the rules are different right now, right? Is that something that you or Michael, you or Aaron could address?
Yes, I'm saying it's a unique situation. So again, today's for teachers. So knowing in later years, this question would be a non-calculator question. We know that. This year, just because it's weird, yes, I could see a little bit of problematic something with this problem. So I would say, I would leave it to the teacher's discretion on that part for this. Yeah.
I would say this is also a place where we spent I would say like 3 days writing these questions. The test development committee is going to be working on this for a while longer, and they've had questions.
Right. It would have came up. Yeah.
That would be a thing that would show up, and they would be careful about.
But yeah. Good question. Good question.
Yeah, absolutely.
All right. Snippets.
Oops. Let's see. Page up. Snip 1.
Yeah.
There we go.
So we'll take about 15 seconds for you all to take a look at it, and then we'll throw the poll up.
All right. Poll's up. All right. Let's see. On this one, they've got the correct 2 terms Next terms are correct. They've substituted in the 1/4. There's no need to simplify. So this is a 1, 1, 1. Okay, next one. All right, the poll's up. All right. Pops right in front of everything. Okay, on this one, we see they have x minus x squared. Those are correct, but the next one is wrong. That's a 1, 0, and we are going to allow them that last point the way we came with it, so it'd be a 1, 0, 1. That probably could be stricter because of the simplification that could happen. Like there's so many ways that they could simplify that and we couldn't see that it was easily made. So we went back and forth on that one. Alex, do you want to chime in on about that?
Yeah, I agree. I think this is a place where there'd be a lot of careful conversation about what are the eligibility criteria for reading on for an approximation.
All right, is this the third one? Yeah.
Yep.
I apologize if there's a little bit of background noise on me. My wife's also a teacher, and she's on a faculty meeting call. All right, on this one, we have, this is the C one, right? Yes, they have the correct terms. They've substituted in the 1/4, and they have 0.2. We will accept that because 0.200 is correct. When that happens, you can take off the zeros. I know it's a little confusing. They don't have to show the zeros to be considered correct to 3 decimal places. So this is a 1, 1, 1.
And we are allowing also that equals in this place. We don't need to see that. We're not requiring the approximately. Be more comfortable to see approximately because they are rounding off that. I'd be more accurate to say approximately.
Yeah. All right, last snippet for this one. All right, this last one, this was what we were thinking of as minimum accepted, but also if they had substituted in the 1/4 we talked about, kind of like this. So here they produced the correct polynomial and skip straight to the answer. We're going to say this is a 1, 1, 1. This is on the same lines as if it had the x's were replaced with 1/4. Still would be a 1, 1, 1. All right. Questions, Aaron?
A couple quick questions here. Do students need to link that the Taylor polynomial is the approximation for h of x?
Sorry, one more time.
Do students need to link that the Taylor polynomial is approximating h of x? Or is the approximation for h of x?
No, like right here, there's no need to have an h of x here.
All right. And then the other things were just a couple tips. One teacher said that students should not be using ellipses this year because we're only asking for polynomials on this year's exam. And just to reemphasize the fact that students can use calculators, however, none of the questions will require them.
That's correct.
All right.
Excellent. Okay. All right, so let's go on to BC2D. And so the last part is we're kind of breaking off. It's just a completely separate part of the question. Actually, I was thinking about this. A thing I tell students that I work with sometimes is, right, try all the parts, right? Just because you couldn't maybe get, parts A, B, or C, it doesn't mean that D is not accessible. And so this is a case where there's kind of a reboot of the whole question, and a student who maybe doesn't know what to do on the first parts could have some success. And that was part of what we were thinking about in designing this. So we gave them a series, right? The series from 1 to infinity, the third root of n in the denominator, -1 to the n, this alternating series. And we asked them, does it converge or diverge? I don't know that a question like this would be on a regular year's exam, but we don't have any multiple choice this year. And so I don't know. And I do think this is an important question in terms of what are we asking them to do? We're asking them to think about using a theorem. We're going to think about the alternating series test or the Leibniz test. And an important part of using theorems is that you have to make sure you satisfy all the hypotheses and that you communicate that you're thinking about all of them. And so in that sense, this question has a little bit of a high bar to it. We're going to be looking for convergence, and then we're going to be looking for explanations. Right, so so states the series converges, we need them to state the series converges. So they have to give us the answer that they've settled on. So that's it for the 9th point. I don't know, I went back and forth a little bit about, do we need to see something else there? And I don't remember if we explicitly talked about that or not, Michael and Aaron, but there might be a place where you'd want something a little more robust than just the word converges on the page. But that seemed to work for what we were thinking about for today. To earn the explanation point, you can only explain correct answers, might be a way to think about it. So they have to have earned the 9th point. They need to be saying that it's converging. And then we're going to be looking for 3 things and thinking about using the alternating series test. We need them to explicitly talk about the terms alternate in sign. We need to have them say that, right, the terms decrease in magnitude, or the absolute value of the terms is decreasing to 0, or is decreasing, I'm sorry, just decreasing. The third point is the approaching 0. We might see that expressed in terms of limits or words. Right, again, a little bit of the philosophy, right, part of the power of mathematics is the notation and the symbolism. So we might see these things written out using that, or we might, right, people using words to say these same things. So that's really all we were thinking about as far as criteria for the 9th and 10th points. So, we're ready to talk about Snips then, and how those two would be graded.
Great. Here's our first one. I'll let you look at it, and then Aaron will put the poll up. All right, so here the student did say converges, so they earned the first point. Just stating alternating series test is not enough. We need to see all 3 of the elements, so this is a 1, 0.
This might be I don't know, we were talking about bald or unsupported answers. This might be the kind of thing of like just writing the word converges might not be enough, right? But some indication is alternating series test. So I guess I don't want to change the criteria for how we're grading, but I think that would become a part of a discussion that would happen after a table leader briefing. So.
Yes. Okay. Next one. All right, so on this one, we can see they have the series, but they say diverges. So that's not going to be correct. So they cannot earn either points. So it's a 0-0. All right, the third one. Okay, this one, we had some discussion. We see that they say converges. So they've earned the first point. Then we see because the terms alternate and go to 0. Well, we're looking for alternating terms, decreasing in absolute value and going to 0. They're missing one of those. They do not discuss decreasing. Goes to 0 is not enough. So we're going to say 1, 0. All right, here's the last snippet.
Mm-hmm.
Okay, on this one, it's better. They talk about the absolute value of the terms decreasing to 0, but the first thing I noticed is they did not state that the series converges. So they cannot earn the first point. And then they've also not told us that the terms are alternating. I know they've written it, but they haven't explicitly said it. So this is a very frustrating 0-0.
Yeah, we really need the student to reach a conclusion. They need to tell us it converges, or even if they had mentioned alternating, they wouldn't tell us that last point. They need to tell us what, the conclusion they're reaching before they can explain the conclusion.
Yeah. All right, Aaron, questions?
All right, first question is if a student writes 1 over into the 1/3 is greater than 0, rather than saying the terms alternate, will that work?
I don't think so. I think they need to tell us out of all the possible series in the world, right? What's the version that they're working on is an alternating one. The alternating series test requires it only applies to alternating series. So we need that hypothesis addressed. Yeah.
Okay. And then two other questions just on how strict you all are with students explicitly saying that the terms alternate. If they apply the alternating series test, and also state the conditions, will that be sufficient?
We have, you're saying they don't say alternating, but then they say they use the alternating series test?
So
Because
if
we
a
haven't,
student states that they are using the alternating series test and then states that the limit to infinity is 0, will that work?
we have a sample coming up that does
And
that, remember, Alex?
the terms decrease in absolute value. So if they're stating the two conditions for using alternating series test, do they still need to state that the terms alternate in words?
I think well, and
Yes.
I think, yeah, we landed on, so I guess what's the principle that we were thinking about when we wrote down you need all three elements, is that students have to verify all the hypotheses of a theorem before they apply the theorem. And right, one of those hypotheses is that you're looking at an alternating series. So they need to address that explicitly. It's kind of like the mean value theorem, right? That you have to talk about differentiability and continuity. You can't say, oh, right, one's implicit. So I think, yeah, but these would be, right, if they said alternating series tests and 2 and 3, that would be a thing I think I would want to think about some more. I don't know, does that make sense, Michael?
That does, and they're going to see that soon.
Maybe that stand-in for one is if you say alternating series test, right?
Yeah.
Say the alternating sign or say alternating series test. I could see adjusting that third element. And I would want to see how it read with as table leaders looked at. Were there other questions, Aaron? Or?
No, those were it.
So Aaron, you want to do some?
I'm sorry.
Is it time? Is that time for samples? Aaron?
Yeah. So here's how we're going to do this. We're going to experiment with breakout rooms. Please make sure you go to the bit.ly mock exam 2020 link and make sure you have BC2 samples 1 and 2 pulled up. Momentarily, you will be divided up into breakout rooms where you will be able to move to your own room. So wait till you click it because then you won't hear anything else. So in your breakout room, you'll be with 4 to 5 other people. Your task is to score the first sample together. We'll take about 3 minutes to do that, and then I will close the rooms and you will move back to the main room. If you finish before that, you can move back to the main room as well. But you'll have 3 minutes before we cut it off. Only score the first sample. When you come back, we will go over that first sample and then we'll repeat with the second sample. So we are going to do that now. Fingers crossed. Alex, if you want to go ahead and resume, we can score sample 2 together or sample 1 together and see how everybody's scores lined up.
All right. So, yeah, I know it's kind of hard to read, but then I thought to myself, wow, that's what it's going to be like this year. So I'm real curious to see how this is going to work. All right. So this student in part A, I can already see some problems, but I do want to see if they can earn that first point with 2 correct terms. And I see that negative 2x and the plus 4x squared are correct. So this would be a 1, 0. Okay, in part B, we have a lot of work. I see that they've imported, though, from part A, obviously. Oh, I'm sorry, in part B, they have, that's not the import that we said that we would accept. We only had 1 import we would accept for that one. So this is going to be a 0, 0, 0. Okay, part C. Now we got to think about the import again. We said it has to have at least 3 terms and be cubic. And okay, this fits. So now I have to carefully make sure that they take the correct antiderivative. Believe they have. They have substituted in 1/4. It'd been great if they stopped there. They did not, so we have to check all the arithmetic. And I believe that gives us the correct answer. Oh, I'm sorry, the incorrect, that's a negative 17. Yeah, it's supposed to be,
Well,
oh, for them, I'm sorry, thank you.
yeah.
I did check, and that is the answer you get with their work. So yeah, sometimes you have to pull your calculator out and work with them. It's a 111. Thank you, Alex. Yeah.
Yeah, so that consistent answer, and this would be an example of that case where we have to think very carefully about that eligibility criteria. Yeah.
And then part D, we see that they say that it diverges. So we know this is going to be a 0, 0. So I believe that gives us a 4 out of 10.
Yeah.
So questions, Aaron?
No questions are popping up, so we're going to move on to sample 2.
All right.
Same process. We'll make the breakout rooms a little bigger so there's more discussion. And then any of the co-hosts here, we will jump in if we see the need to. So have sample 2 in front of you. Here we go.
Okay. So if we look at this one, it looks like good work. So part A, carefully look at the terms. Seems that all 4 are correct. No need to simplify. So that's going to be a 1, 1. Okay. Part B. Okay, I glance down and see that sum has the negative 1/2 in the R position. We said you can earn the first point for that. They say it converges 2/3 and there's work, but I never see anywhere stating about how the absolute value R is less than 1 leading to convergence. So we're not going to earn the middle point. They have 2/3 correct and the work. So this would be a 1, 0, 1. All right, part C. Wow, that one's really, really well done. So that's a 1, 1, 1.
That's one of y'all students, right?
All right, that's a student to be jealous of. That's awesome. All right, and then part D, we see that they're attempting to talk about the limit going to 0. That's good. That's one element. The next one, it seems like
they've got that converges. Like I just think as a reader, you want to go through and like look for converges somewhere before you.
Yeah. They do have the converges point. Sorry, thank you. Yeah. So we do have the first point. So now we're looking for the elements. So they do have that the limit of the terms goes to 0. They check that off. Now the next, it looks like there's an attempt to talk about how the next term's always less than the term before it. They've slapped a limit on there. I think we've said without that limit, that would be good. So that right there, I think, is going to make them not earn the point. And the other discussion we had it earlier, is they also never said the series alternated, but they did say they used the alternating series test. So we've scored this a 1, 0. Yeah. I think the discussion we had earlier is if that limit had not been there, we counted that, would we have accepted that since they said it was alternating series test, that they implied the terms alternate? So that was the discussion we had earlier.
Yeah. Yeah, so this is without that limit. I think this is potentially a 1, 1. I think, this would be a case where we want to talk about that and think about that. I lean towards without the boxed limit, that being a 1, 1. But you have to process more with some people.
All right, Aaron, I think that's all.
All right.
I have for the samples.
And then let me throw up one more slide here.
Oh, here, give me a stop sharing.
Yeah, you're good.
Okay.
All right. So that does us for today, right at noon. Those of you that wanted to see the BC1 question, that is the same as the AB1 question. So please refer to kyap2020.com/calculus, I think, and you can find the recording of Alex and Michael going over that, as well as you can find the handouts as well as student samples in the bit.ly link. So again, all of our contact here is on the screen for Advanced Kentucky, for myself, Michael, and Alex. A link to the handouts. Today's recording that you just finished will be posted by the end of the day. And then tomorrow, those of you that have that want to go back and tell your students, please have them join and register for our Apbc review session with Amy Cash, NIMSY consultant, Bowling Green high school teacher. So she will be here to work through last minute BC tips as students prepare for the ABE exam next week. So again, Alex, Michael, thank you very much. I think that this gave teachers, regardless if they're experienced readers or not, insight as to just how a reading goes and those decisions that have to be made about briefings and everything else. So unless you two have further questions or closing remarks, we will sign off.
I just wish all you and your students well for next week. I know it's been a rough time, but I think you got this.
And I think I would just want to echo that, right? This whole spring has been so tumultuous, and all that you're doing as teachers to support students learning calculus right now with all the rest that's going on. I mean, we got the same kind of thing here. It's really challenging, and it's just great work, and I'm grateful to all your investing. So.
All right, and again, this is Teacher Appreciation Week, so a very, very special thank you. Happy Teacher Appreciation Week to all of you. So I know you all are doing incredible work, especially in these unique times. So kudos to all of you. All right, so if there's nothing else, we will sign off. Good luck to all of your students. Hopefully we can see some of you all in the session tomorrow. So we will see you then.
Thank you.